In our third success criteria for this unit, we are going to learn how to classify the elements of the periodic table in terms of groups, families, and characteristics. But in order to do that, we are going to have to define some general patterns on the periodic table. The first is the concept of a period, and a period on the periodic table are when elements are placed in order by atomic number. So this means that the elements are organized by the number of protons in the nucleus. A period is the chemistry terminology for a row of the periodic table. The second vocabulary word you're going to have to be familiar with is a group, and groups are also often called families. So a group or a family is when elements are placed into a vertical group based on shared chemical properties. So a group or a family is another word. It's a chemistry term for the column of the periodic table. But how do we figure out if elements have shared chemical properties? Well, the number of valence electrons determine where each element is placed vertically on the periodic table. So based on these two statements, we can assume or we can conclude that the number of valence electrons indicate the chemical properties of an element. Now, there's many different types of ways to classify elements, and the most basic is determining if it's a metal, a nonmetal, or a metalloid. 80% of the elements on the periodic table are metals, and metals tend to lose electrons and become cations. And for the most part, metals are located on the left-hand side of the periodic table. So this is left. So this is where the majority of the metals are going to be. So we're going to color our metals red. So in our first column, or column number 1, every element except for the top element is a metal. In the second column, every element is a metal, and there are no exceptions in this particular column. In columns 3 through 12, or this lower part of the periodic table, these are all metals also. These two rows down here, these are also metals. And for the right-hand side-ish of the periodic table are when things start to get a little bit more specific. In the 13th column, in this first column after this lower part, every element except for the top one is a metal. In column 14, everyone except for the top 3, so 1, 2, 3 are metals. In the 15th column, only the bottom 2 elements are metals. And then for the remainder of the columns, the bottom ones are considered metals. The opposite of a metal is a nonmetal. And nonmetals tend to gain electrons and become anions. And nonmetals are typically found on the right side of the periodic table. So remember that this is the right side. And let's take a moment and we're going to color our nonmetals blue. So then let's work right to left. In column number 18, so the furthest right-hand column, all of the remaining elements in that column are nonmetals. In column 17, all of those remaining elements are nonmetals. In column 16, only the top 3 are nonmetals. In column 15, only the top 2 are nonmetals. And in column 14, only the first one is a nonmetal. While there are no nonmetals in column 13, we have to go over to column 1 because there's one lone nonmetal in the first column. The last type of element is a metalloid. And you might notice we left very specific element squares blank. And it kind of looks like a stair step. So that's what we call it. We say that the metalloids are a stair step that divide the metals and nonmetals on the periodic table of elements. Now, the strange thing about metalloids is that they can have the properties of both metals and nonmetals. So they're sort of in between. So we're going to color our metalloids green, and those are the remainder of our blank elements. Now let's compare the properties of metals, nonmetals, and metalloids. So when you think of a metal, typically you think of something that's shiny. In chemistry, we call that luster. Nonmetals are typically not shiny. And metalloids, it kind of depends on what we're dealing with. So silicon is sometimes really shiny, but sometimes it can be dull. And gallium is sometimes shiny because it has some of the properties of a metal, but other metalloids not so much. The state of matter that metals are in are mostly solids. There is, of course, an exception, and that exception is mercury. Mercury is the only metal that is a liquid at room temperature. Nonmetals are typically gases and liquids. And we'll get to metalloids in just a moment. Metals are malleable and ductile. So what this means is that we can form metals into different shapes really easily, and they hold their shapes, which is part of the reason why a lot of sculptures are made out of metals. Nonmetals are typically brittle. So if you think about sulfur, which some of you might be familiar with, it's actually a loose yellow powder, but it's very, very brittle. Metals are excellent conductors of heat and electricity. Which is why copper wiring is used in homes to run your electric. And also most heat pipes are made of metal as well, or radiators rather. Nonmetals are poor conductors of heat or electricity. But to speak of it in a more positive light, they are good insulators. So for example, if you have porcelain, which is a type of clay, they make a really excellent insulator. Think of your coffee mugs. Those are all made out of porcelain. Metals also typically have a higher boiling and melting point. Which makes sense that at the higher a temperature needed to boil or melt this object, that's why it's a solid. While nonmetals typically have lower boiling and melting points. Which makes sense that because at a lower temperature they'll go from a solid to a liquid, that they would be liquids more often than not, and then they would become gases as well because of their low boiling point. So in terms of metalloids, it gets a little confusing, but there's a general rule of thumb. Metalloids, their physical properties, so what they look like, their texture, their densities, what have you, are typically metallic in nature. While their chemical properties, their flammability, their reactivity, are typically non-metallic. And there's a reason I left this box blank. So if metals are excellent conductors of heat and electricity, and nonmetals are poor conductors, we would assume that the metalloids are somewhere in the middle, and they are. They have a very special name, and they're called semiconductors. So if you're interested in wiring or sound or computers, you will have heard of semiconductors because those types of elements are used in computers in terms of their inner wirings and their hard drives. After we turn the page, we're going to see that there are a multitude of families on the periodic table that we need to know some basic information of, specifically their names, where they're located, and if they're stable or not. So looking at this first family or group, group 1 is called the alkali metals. And the alkali metals include the elements in the first column except for the top one, which is hydrogen. So hydrogen is considered to not be a member. And let's think about why. Hydrogen is a non-metal. So it clearly does not belong in a family with the word metal in it. But the reason it's placed over here is because it has one valence electron. So it fulfills that requirement to be in that particular column because everyone in that column or group has one outer electron. Alkali metals are extraordinarily reactive. They will react with air or water, but before they do so, they tend to have a silver or a white appearance. And alkali metals are excellent conductors of electricity. The second group or family, those are called the alkaline earth metals, and that includes everyone in column 2. Everyone in group 2, as we discussed in our Lewis dot diagram notes, has 2 outer electrons. These are also typically silver or white. They are also chemically reactive, but not as reactive as the alkali metals, and they too can conduct electricity. The biggest group we have is groups 3 through 12 rather, I'm so sorry, and that's this lower portion of the periodic table. And this family is called the transition metals. And you are familiar with a lot of transition metals because they'll make things like jewelry, like out of gold and silver, or wiring, like out of copper, out of these transition metals because they're extremely stable. So they have a varying or changing number of electrons and their outer level. We call these delocalized electrons. And the reason that transition metals are excellent conductors of heat and electricity, and the fact that they're so stable, are because of these delocalized electrons. And they have a really fun term. They're called a sea of electrons. So it's a really nice mental image there. Going into group 13 is the boron family. This is where things are getting a little less clever, and that includes everyone in column 13. All the elements, metalloid or metal, have 3 outer electrons, and most of these elements are metals, except for boron. So instead of some are, we can say one is a metalloid. The next family we have to talk about is the carbon family. Again, not super clever in terms of naming. And group 14 is known as the carbon family. And in this particular family, they all have 4 out of electrons. But what kind of elements are in this group? Let's turn the page back over. So in group 14, we have a nonmetal, a metalloid, and some metals. So we have a representative of all the different types of elements in this family. So we have a nonmetal, we have 2 metalloids, and we have some metals. Our next group is the nitrogen family, because nitrogen is on the top of that particular column. The nitrogen family. And the nitrogen family is the first family where the majority of them are nonmetals and metalloids. So the elements in this group have 5 outer electrons. So because these are nonmetals, not only do they tend to gain electrons and become anions, they also tend to share their electrons when they form compounds, and this is called covalent bonding, which we'll talk more about in our next unit. The next family in the line is the chalcogens. The chalcogens, that's more of a fun name for us. And the chalcogens include one of the best elements, and that's oxygen, because it's extremely electronegative, which is something we'll also talk about later this particular unit. So the chalcogens all have 6 outer electrons, and this is the first family where we have all nonmetals. And the chalcogens are chemically reactive. So they're very reactive. In group 17, we have the halogens, and the halogens are a funner group. These halogens are extremely reactive. They have 7 outer electrons, and typically they will bond with alkali metals to become stable based on the octet rule. Because think about it. So if the halogens have 7 outer electrons, and the alkali metals have 1, if you put 1 of each of these elements together, they'll have a full octet between the 2 of them. And we're going to talk significantly more about the octet rule when we study bonding next unit. And last but not least, we have the noble gases, and that does include helium up at the top. The noble gases are group 18. What state of matter do you think these elements are found in? Well, it's right in the name. They are gases. What kind of elements are in this group? So if we go back to the beginning part of our notes, mostly nonmetals. I'm going to be really honest. These metals only exist in the lab, so we don't really consider them when we talk about different types of families, especially at the high school level. So these are all nonmetals. And this is the only family that's chemically stable because of their full octet. So their outer ring is all filled up with electrons, and they're very happy and satisfied and stable. So I understand that was a lot of notes, and you guys did a really fantastic job. But if you take these notes into consideration and you go back and check your color coding, you will understand how to classify the periodic table in terms of metals, nonmetals, metalloids, understand those properties, and then also be able to determine the types of families and explain why they have similar chemical properties. So nice job today, guys.